Tolerance. Who said tolerance? Okay. Wait, we come back for tolerance. What else?
Labor.
Labor. What about labor?
Man-hour to produce the final product.
Okay, so labor, you're talking about hours and money.
Manufacturing techniques.
Manufacturing process.
Quantity, like how many products you need.
Quantity. Huh? What else?
Quality control and checking.
So there is tolerance.
Logistics.
Logistics. Wow. What else?
How many of the products that are needed to be manufactured?
So we not quality, quantity. Sorry, we have UNTI, quantity. What else?
Limitations.
Limitation. You mean limitation of facilities, right? That's our equipment.
Yes.
Testing of the various. Sorry, testing of the various materials.
Huh?
Testing of the various materials.
Testing.
Is there going to be any coating or anodizing?
Waste management.
Waste. Oh, that's a big one.
Yield with the waste.
Okay, that's under waste and yield. Okay. Now, all these are good questions. Okay, these are the things that you will ask. Another thing that whenever we ask about material properties, we ask about the what? The hardness. Okay. Now, question for you guys. Why is tolerance so important? Tolerance is a big thing. Okay. Tolerance is one of the most painful, okay, number to specify in your design. Okay. So I don't know how much have you guys done in tolerancing. Okay, I'm not a clue. Have you all applied tolerance in your courses yet? Anyone?
Yes.
Right. So I hear one yes. I believe most of you have done it before. But why you tolerance at that particular value? Any idea?
Different machines have like different amount of tolerance that they need for proper manufacturing. So for example, a 3D printer versus a CNC router might need a different required tolerance. So you could have a certain fit for your product.
Yeah, but so okay, you're right. Okay, so your tolerance is based on your manufacturing process, right? Am I right?
Yep.
Okay, so
yeah, isn't it based on the intended use as well?
What do you mean by intended use? Intended use.
For example, for mold manufacturers, there's still off faces between two plates, and it has to be tight within tolerance of, let's say, 1 thou or half a thou, or maybe 4/10. Whereas all the other molding surfaces, they can be quite flexible in terms of the tolerances, in terms of the angles and stuff.
Yeah, but okay, I want you to think this way. Okay, now tolerance is critical.
What about the fit? It depends on the fit. Some stuff is tight fit, some is a little bit loose.
Yeah, yeah. So all this play a part, especially in a hole and shaft situation. Yes or no? Right. So that's a good. So tolerance, okay, it depends on. I'll give you an example now. Okay. So now we have the tolerance can be A or B. Okay. A is plus or minus 0.5. Okay. B can be plus or minus 2.0. Okay. Now, in the product design, the tolerance given is you can go within plus or minus 2.0. That's your product design. Okay. Right? So this is your product design. You say plus or minus 2 is okay. it's okay, right? So if you look in terms of cost, product A will be more expensive or cheaper. Anyone?
More expensive.
More
Yeah, it's
expensive.
costly. Okay, and this one is cheaper. Okay. Now let me ask you a question. Or I'm going to exaggerate. Okay, I'm going to exaggerate this. Okay, so let's say it's a hole and shaft situation. Okay, so there's A. This is B. Okay, A has a tighter fit, so this is a shaft. This is the hole. Because it's tighter fit. Okay, this is exaggerated. Okay. So the one I draw in orange, right, is the shaft that's going in. Okay. And then the other one, okay, the tolerance is more loose. Okay. As I said, this is exaggerated. Okay, so that's the tolerance. Okay, so these are the shaft. Then someone tell me what are the outcome of this? Anyone?
Depending on the application, it could, for example, for the B situation, it could easily destroy the shaft and the hole as well because of the constant moving, because of the excess room. A would be, I feel it would last longer in that scenario.
So your outcome is right, but the reason is wrong. Let me tell you what's going to happen. If you look at the contact area, right? So this is the contact area, right? And over here, this is your contact area. Okay. So you can see the contact area for A is bigger than the contact area for B. So if you have a applied force coming down here like P, okay, you have applied force P, your stress A will be equal to P divided by area of A. Okay, stress B will be P divided by area of B. So you know for the fact that area of A, the contact area, is greater than area of B. So stress A, right, will be lower than stress B. So in terms of product life, right, A will last longer. Okay, I want you to think of consequences like this. I know this is going to be cheaper. But if you look at the economy of things, right? This thing, if this thing will last for 10 years, this thing will last for 3 years. Okay. So as now you put your head into business now. Okay. So what this means is, if you have a client that use tolerance A, right? He only need to change this part every 10 years. Whereas B, every 3 years, he has to come back and buy from you. You'll get one coming from, right? So how often, so what is a successful business? A successful business, can any one of you name me a company now that is very successful? Come on, anyone.
Apple.
Tesla.
Yeah. Let's not talk about Tesla first, okay? I have a lot to say about Tesla. Okay?
Toyota.
So, huh?
Toyota.
Yeah.
Amazon.
So Apple is a good company to mention. Why? Because they always upgrade their phone every year. And listen to me, now the economy is not doing well at all. Okay? It's true. Now the economy is not doing well at all. But have you been to an Apple store recently? It's always what? Crowded. It's always what? Packed. Because everyone wants to buy a new what? Cell phone every year if you can afford it. Now I'm going to show you my cell phone now. Can you see my cell phone? Right? Can anyone guess? It's a Samsung. Can anyone guess what's the model? Anyone?
S5?
Hey?
S5. S5.
Oh, you guys are good. My phone can still take up the battery. Can you all see that? Okay.
Yeah.
How many of you, your phone can take out battery within less than 2 seconds? How many of you? This is the reason why I keep this phone. Okay. Anything go wrong is always the what? The battery. Okay. I can change the battery every time. So they realize that this is not a very good business model. This is a Note 4, by the way. Okay. I don't know how long I think it's going to be 8 years now. Okay, a Note 4, and it's still working. Okay. So why I could afford any phone now, but I don't want to, because I'm thinking about the environment. Okay. The environment is a key factor down here. Okay. Now coming back to this situation over here, right? This is how critical tolerancing is. Okay. I'm not saying 3 years is bad. Okay. If the product, right, lasts 3 years and your competitors also last 3 years, go for this solution. Because your competitors are also lasting for 3 years. If your competitor makes something that lasts for 10 years and are cheaper than you, you're in trouble. Okay. So I'll give you an example. Okay. How many of you know a car company known as Hyundai? All of you know a company. Yeah. Right?
Yeah.
Sad to say, I will buy a Hyundai today. But 5 years ago, I will not touch that car at all. Because it is cheap. Not only cheap, you need to buy 2 Hyundais to last for 5 years. One to drive, one for what? Spare parts. Now, they're as good. Okay, now they're as good. Okay, because of knowledge-based economy. Okay, they understand their manufacturing process, and they understand what are critical in controlling tolerance and what are not. Okay. Now, next thing I want to highlight is this. Okay. At present, I still do consulting to companies. Okay. I always have calls from companies. Okay. Some of you might say, what company do I work for? Okay, I've done research for the US Army. Okay, down to Linema. Okay, a wide range of companies, and expert witness myself for the Queen's Court. Now, people or engineers always ask about hardness. The first question they will ask is, what is this material? The second question they will ask, a lot of engineers does this, okay, is how hard. And I want gadgets from McMaster to stop asking that idiotic question, how hard? It's not important at all. Okay, some of you might say, hey, some of you are working industry. You say, Eugene, that's always the norm. I will ask what material and how hard. In manufacturing, asking how hard is a very redundant question. And I'll prove to you why. And I learned the hard way. Okay, I learned the hard way because I was a mechanical engineer in 2008 implementing solution. Okay, I hate material science. I hate it. Okay, and I'm a hardcore mechanical engineer, and I will still ask what material and how hard. Later on, I'll show you in a case study. Okay, asking how hard has no value. Okay? It's just information, has no value for you to optimize your process in manufacturing. Okay, now let's do some simple fundamental work first. Okay, what are the key information that you need to gather? Okay, so the first thing of all, I'm going to draw a stress strain